All right, let's get serious about HVAC. When you see those letters HVAC, you know they stand for heating, ventilating, and air conditioning, HVAC. The organization that writes standards for heating and cooling is called ASHRAE, and that stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Can't remember I don't think we have a local ASHRAE chapter in Eugene. We used to, I'm not sure we still do. In any event, ASHRAE produces all kinds of standards that we use to decide whether our heating and cooling and air quality is good. So for example, 90.1 and 90.2 are energy standards. They say how energy efficient your building and your equipment has to be. 62.2 is an air quality standard for houses. So it says how many air changes per hour you have to have and how much particulate there can be in the air and so forth. So if you work in the field, you are going to be using ASHRAE handbooks and standards a lot. If you work with air conditioners and things like heat pumps, things like that, you are using what's called a mechanical method, an active method. So you are using electrical equipment to do this work. And with air conditioning, well, anytime we're cooling, you cannot add cooling. That's not a thing. All you can do is add more heat or remove heat. So there's only heat. Cool is an absence of heat. Cold is even less heat, but we're still talking about how much heat is there. So with an air conditioner, with a mechanical system, the air flows into the thing, it gets cold, it gets blown out into the room. And we measure cooling in tons. So you'll hear technicians talk about, oh, that's a 3-ton unit right there. Why do we call it a ton? It comes from many decades ago, when we used to cut ice out of frozen rivers. Anyway, if you have 1 ton of ice, so in the US 1 ton is 2,000 pounds, you have 1 ton of ice and it's 32 degrees Fahrenheit. How much energy does it take? And think about latent heat now. How much energy does it take to change the state of that solid block of ice to liquid, still at 32 degrees Fahrenheit? How much energy in exactly 24 hours? So 1 ton of cooling is the amount of heat absorbed when you melt 1 ton of ice at 32 degrees Fahrenheit in 24 hours. And if you like, you can convert a ton of cooling into BTUs per hour, which I've shown you in the bottom there. And here's some more math. Let's not go over that, but here are a couple of examples in the bottom of the slide. Let's say you have a small house like mine. If I were to get a heat pump or an air conditioner, I might go for a 2-ton unit. If you're in a slightly bigger house, let's say a 2,000 square foot house, you might get a 3-ton unit. Air conditioners and heat pumps use a refrigeration cycle. So there is liquid refrigerant, some kind of Freon. Freon is a brand name made by DuPont. There's liquid refrigerant flowing through this system. There are tubes. And it's all about latent heat. So if the liquid refrigerant changes to gas, like think of boiling, it absorbs heat. And so it could absorb heat out of your room. It's all about latent heat. So there are 2 devices that constantly change this refrigerant, this Freon, from liquid to gas and from gas to liquid. And here is just a conceptual diagram. This isn't what the thing really looks like. The evaporator, you can think of the word evaporate. That must be the thing that turns the liquid into gas. It absorbs heat when it does that. The condenser is the thing that condenses the gas back to liquid. It releases heat when it does that. So here's a little bit of a pictorial. Here's the evaporator. The liquid changes to gas and it goes through some tubes. The compressor is sucking that gas through the tubes, and then it gets over there to the condenser, and the condenser condenses that gas and changes it back to liquid, and it goes back to the evaporator. And here in the evaporator, by the way, there's a heat exchanger, kind of like a radiator in a car, kind of like an evaporator on the back of your refrigerator. If you go to the back of your refrigerator and you put your hand on those coils, those fins back there, you'll notice it feels warm. Where did that heat come from? That heat came from the food that's sitting inside your refrigerator. So here's just a brief description of the cycle. There's also an expansion valve in there, by the way. A heat pump is an air conditioner with a reversing valve, is what it is. So in the, let's say, summertime, you want to pump heat out of your house and dispose of it outside. In the winter, you pump heat out of the outdoors and you pump it into your house. And believe it or not, you can pump heat out of the outdoors even when it's winter time. Now, they tell us, or they used to tell us anyway, that a heat pump is most efficient when the outdoor temperature is 40 degrees Fahrenheit or warmer. It will still work at colder temperatures, but it's not as efficient. And they call it a heat pump because it is actually pumping heat. In the wintertime, some technicians like to say they're pumping it uphill. In other words, it's cold outside, but you're still pumping heat out of that air into your house. Both heat pumps and air conditioners and refrigerators and freezers use this same refrigeration cycle. So if you went to work for a heating, cooling, refrigeration company in town, you would be all about the refrigeration cycle, and you would understand all these components in this cycle and what the refrigerant is doing, whether you're talking about a heat pump, an air conditioner, or a refrigerator. And the same technicians work on all those systems. In your house, with a heat pump, they talk about air to air, which means we're pumping heat out of the outdoor air into the inside of the house, or we're pumping heat out of the inside of the house, out of its air, and sending it to the outside. There is also such a thing as a water to air heat pump, but when we talk about our houses, we're usually talking about air to air. And we could have just one system sitting on a pad outside your house. You've probably seen these around. Or we could have a split system where we have part of the unit outside and then part of the unit that's the air handler inside. You'll notice in these two pictures that there is ductwork carrying the air into or out of the system. Ductwork, sizing the ductwork especially, is really important with a heat pump, and heat pumps do require a fairly good size set of ducts.